And now on to our sixth example. We are going to be simplifying this radical expression here, cube root of 4 minus cube root of 2 quantity times the quantity cube root of 16 plus cube root of 4. So this is going to use the exact same foiling technique that we've dealt with so far. Very little difference from the first several examples, but I figured one more example of this type would not hurt at all. So let's figure out how we do this. Starting with what we have cube root of 4 minus cube root of 2, and we have these two quantities being multiplied together. So same old foiling technique, we're going to take this first term and we're going to multiply it to each of the second quantity's terms here. So we have cube root of 4 times cube root of 16 plus cube root of 4 times cube root of 4. So we have cube root of 4 times cube root of 16 plus cube root of 4 times cube root of 4. Okay, so that handles these two things being multiplied to this guy. Now we need to do the second one. Foiling in the exact same way you would with polynomials, be minus root 3, cube root of 2 times cube root of 16 minus cube root of 2 plus cube root of 4. Times cube root of 4. The joys of being numerically dyslexic. So we have cube root of 2 times cube root of 4. All right, so this is all completely multiplied out correctly. It's all FOILed. You have 4 terms, and you should because you took this guy and now you have 2, and now you took this guy and now you have another 2. So always make sure that you have the number of terms of the first times the number of terms of the second in total when you have FOILed everything out. Okay, so now how do we combine these two guys together? Let's first look at this. We have a cube root of 4 and a cube root of 16. Let's put those all under one roof. So we have 3 times 4 times 16. We'll break those down in the next step. And we have put these all under one roof. So I have cube root of 4 times 4. We'll break those down in the next step so we can cancel out this radical as much as possible. We have cube root of 2 and cube root of 16. We'll put those all under one roof as well, and we'll break those down. And we have, finally, cube root of 2 and cube root of 4 multiplied together, so I get 2 times 4 in there. Hopefully that's legible. And now let's see if we can break some of these guys down. 4 breaks down into 2 times 2. 16 breaks down into 2 to the 4th power. Okay, so I'm going to resist the urge to use a factor tree here and see if I can do this in my head. So I have 2 times 2 for 4, and I have 2 times 2 times 2 times 2, or 2 to the 4th for 16. So rewriting this, I have how many 2's in total? I have 6. I have 2 to the 6th in there. Okay? Now I have this guy, so I have 2 times 2 for 4, and I have another 2 times 2, so I have 2 to the 4th on the inside of this guy. So I'm resisting using a factor tree here. So I have cube root of 2 times 16, so how many 2's do I have in total? 16 has 4 2's, and I have this extra 2, so I have 2 to the 5th inside this guy, and I have, okay, for this one, I have 2 times 4, or I'll have 3 2's in this guy. So I have cube root of 2 to the 3rd in this case. All right, so what can I do with this? Notice that if I have a 2 to the 6th, that's the same thing as 2 to the 3rd times 2 to the 3rd, and that will cancel out in both cases with this cube root. I'll write that out just to detail it. So I have cube root of 2 to the 3rd times 2 to the 3rd, all in the inside here, and the cube root will cancel that in the next step. In this case, I have 2 to the 4th, but that breaks down into 2 times 2 to the 3rd. So I have 4 2's here, I have 4 2's here, we're in good shape. Continuing along this train of thought, I have cube root of 2 to the 5th. 2 to the 5th breaks down into 2 to the 3rd times 2 squared. The idea here is I'm breaking these into clusters of 3 because I have a cube root. All right, now for the last term, hey, look, I already have everything simplified and where it needs to be, so this is just minus 2. So the cube root canceled the cube. All right, simplifying further, using the product rule, this becomes cube root of 2 cubed times the cube root of 2 cubed. Skipping that step, I'm just going to write this as 2 times 2 because I cancel out both these powers with this root. And that's just 4. Okay? And now here in this case, I can't cancel off this 2, this extra 2, but I can cancel off this 2 to the third. So I end up with cube root of 2 times just 2 because I cancel off this radical and the power. So that 2 is not inside this radical. Okay? See if we can do the same thing over here. I have cube root of 2 cubed. Those will cancel, but I have not enough 2's here to cancel the radical. So I'll be stuck with a 2 times 2 squared inside this radical, and then minus 2. Combine everything that you possibly can. So we have a 2 minus, a 4 minus 2. This gives us 2. And now just rearranging stuff. So we have 2. I like to put the whole numbers out in front of radicals. The whole mathematical community does as well. And then I have, that should be a cube root. So I have 2 times the cube root of 4 here, and I already took care of this minus 2. So this is what we're left with here. Notice that I have a 2 in each of these guys, and if I factor it out, I don't really have anything else to factor out of anything. So I can factor out a 2. So I have 1 plus cube root of 2 minus cube root of 4. All I did was factor out this 2 from every single term, and I just pulled it out in front of the entire quantity. So this looks completely simplified. Why? Because these two guys can't be added together. They're not like terms. These two guys can't be added together because they're also not like terms. I have radicals of different stuff on the inside, so I can't combine them. This is as simple as it's going to get. So with that, we are done with this example, and that concludes our difficulty 5 examples for the time being. Might add more later, we'll see. But hopefully you found this helpful, and I will see you probably in the next lesson.